All right, now let's say we want to just find the inverse function with an algorithm, something that's really quick and easy and somewhat painless. So we have a function here. We have kx equals 2x plus 3. So what I would do in this case is put a y in place of my k at x, in place of my function notation. And so that's the same representation of the function as y equals mx plus b form. And what you do then is you can, just like in the inverse of a number, you flip your x and y around, you do the same here. So the inverse is going to be x equals 2y plus 3. And then it's just a matter of solving for y. So I'm going to move that over a little. And so to solve for y, first off I'm going to flip-flop it using symmetric property. So 2y plus 3 equals x. Then, subtract 3 from both sides. So 2y equals x minus 3. And then divide everything by 2. And with a lot less pain and a lot less effort, we've come up with the inverse function of that original k at x. And so then you just replace put it back in function notation, so that's the inverse of k at x is equal to 1/2 x minus 3/2. And so there's your inverse of the function. So let's see if let's know if that's a little bit more complicated. So in this case, we've got g at x equals 2x plus 1 over x. So first off, let's just follow the step 1 of the algebra cookbook. You would start with place y, excuse me, getting late. Y equals 2x plus 1 over x. Replace your function notation, your g at x with a y. And then flip-flop your x's and y's. So x would equal 2y plus 1 over y. Ouch. We got our y split up. So we need to get our y's together. And on one side of the equation, so I'll start out with, we can go ahead and put this over 1 and cross multiply. So xy equals 2y plus 1. And then get your y's together on one side of the equation. So I'm going to subtract 2y. And so xy minus 2y equals 1. Then I'm going to factor out a y. So y is equal to x minus 2. Or use the distributive property to factor out a y. And then last step is we're going to solve for y. So you need to divide by x minus 2 on both sides of the equation. And so y equals 1 over x minus 2. And let's make sure, for some reason that just doesn't look right, but yeah, that's right. Okay, and then, so putting it back into function notation, I do believe we used a g. So the inverse of g at x is equal to 1 over x minus 2. And so let's take a look at what this looks like in GeoGebra. I'll pop up GeoGebra here. I've already got the first function in red. That's our original. So we'll put in our, it's 1 over x minus 2. And I called it f. So we'll call the second one g at x equals 1 divided by, and since it's a quantity, x minus 2. We'll stick that in there. And yep, and hit enter, and let's see what we have. Aha, there it is. And so kind of tough to see the y equals x here, but let's go ahead and see if we can do that. So y equals x, the symmetry of that. Well, there it is. Maybe make that dotted, make it a blue line so it sticks out really nice. And there it is. So you can see very quickly that the, the intersection is in the y equals x realm there. Whoops, and I moved it, didn't mean to. And so, there we go. Put it back. So there you have it. So the inverse is graphed there and in black, and I don't know what else to say. That's it. So we've shown that it's also symmetric about the line y equals x with GeoGebra. So there's an algorithm, kind of a fast algorithm to figure out inverses of functions. So hope this helps. Good luck, and I hope to see you next time.